dilations and similarities in a coordinate plane. So dilation is our word. The definition is it's a transformation that changes the size, but it does not change the shape. Okay, so the shape is the same, but the size is different. Which we know if two items are the same shape, even if they're not the same size, those are going to be similar figures. Now, one way that we can create a dilation is by multiplying by what we call a constant. Okay, so if you're multiplying something by 2, what you would do is you would take your original point. So we call the point AB. Do you have these? Okay. So if you have the point AB, then you would just multiply that by whatever your constant is. So we call the constant K. All right, so if you do K times A, K times B, that's how you would get your dilation. The first thing I'm going to show you is an example. So if you have two rectangles, okay, you can see here this is a 2 by 2. Well, really this is going to be a square because they're all the same. Okay, and then a 4 by 4. Okay, they're the same shape, but they are different sizes. Okay, so we could find the next one by multiplying by 2. So this is similar to some of the ratios that we have been creating for the other ones. Now a non-example, okay, would be if I have a right triangle and then I went to an equilateral triangle. Okay, so it still has to have those same angles like we did before. Now we have something that's called a scale factor, and that's going to be the number that describes how much the figure is either enlarged or reduced. So one thing that you might do a lot of times is people will want pictures blown up. Okay, they enlarge a photo. So there's a scale factor that says how much you want to enlarge it. Okay, or if you're reducing it, that could be a model of something. Okay, so if you wanted to present a model for a new house that you're doing, then you would do a reduced size of that, right? If you're doing some kind of presentation. So the scale factor is the same as the similarity ratio. Okay, it's just called something different when we're dealing with dilations. So the scale factor is the same as the similarity ratio. All right, so now what we're going to do is look at example 1. So we are given our x, our y, and our z. We have to find, this is called x prime. See how it has the apostrophe after it? Right? That's just x prime. Okay, that's going to be an image. So we have x prime, y prime, and z prime that's after a dilation with a scale factor of -4. So if the scale factor is -4, what that means is you're going to multiply the coordinates by -4. All right, so let's start with x. So x is 0, 2. If I multiplied both of those by -4, well, 0 times anything is 0. What's 2 times -4? -8. Okay, so we would call that x prime. Okay, so why don't you guys see if you can do y prime and z prime? Okay, so Baron, what'd you get for y prime?
8 and -8.
Good. Right, so -2 times -4 is a +8. 2 times -4 is -8. Good. Okay, and then Xavier, what about for z prime?
8 and 0.
Good. Okay, so -2 times -4 is 8. 0 times anything is still going to be 0. All right, so this would be your new coordinates. Okay, x prime, y prime, z prime. So what does that apostrophe mean? How is it pronounced? Prime. Okay, good. All right, let's flip it over to the next page. All right, so we have triangle JOK and LOM, and we're going to find the coordinates of M, and we're also going to find the scale factor. Okay, so it already tells us that these are similar. So now what we're going to do is we're going to find the coordinates and then the scale factor. And what I did is I labeled this point as 0, 0 because it's at the origin, so I know that part is going to be 0, 0. So since the triangles are similar, the ratio of their sides are what? Not the same, proportional. Yep, they're proportional. Okay, so you can either label this in the picture, or I like to draw out each one so I can label it. So this would be KOJ. And then I have a larger triangle for MOL. Okay, so let's find the distance from O to K, right? This is at 0, 0. This is 0, negative 2. What's the distance? 2, right? Because your distance is always going to be positive, okay? So the length of this side would be 2. Okay, Sam, what's the length of OJ going to be? Yep. Okay, and Sarah, what's the length of OL going to be? So what's the coordinate at L?
10.
Yep. Okay, so then if you're starting at 0, when you go to 10, it will be 10. Okay, and then for M, you do have oh yeah, we have to find the coordinates of that first. Okay, so do we know what this is to M right now? No, okay, we don't. We know that this is 2, but we're unsure about what this length is right now. So we're just going to call it what? We're just going to call it X. Okay, and now you can set up a proportion. And there's actually many different ways you can set up the proportion. Okay, so you can either start by doing like 10 over 4, that would be fine. If I set up 10 over 4, then what has to go on top, the X or the 2? The X. I could also flip both of those over. I could do 4 over 10 equals 2 over X. Okay, and then I have to solve by cross multiplying. So 4 times X is 4. What's 2 times 10 going to be? 20. So then I'm going to divide both sides by 4. And X will be 5. Okay, so if X is 5, remember that is this whole length here. Okay, this whole length is now 5. Well, we already figured out that this length is 2, okay, which would mean this length is 3 if we needed that. But from there, if you know X is 5, what is this point going to be? 0, negative 5. Okay, so once we know X is 5, we know that point M is going to be 0, negative 5. Yep, go ahead.
All I did was 10 divided by 4 for 2.5, and then I just multiplied k by 2.5.
By 2.5 or by 2?
2.5. The scale.
So if you find the scale factor, so you
So
said
have
you
to
did the
show- Yeah, but do you have to show all the work?
that
Like the proportions.
no,
Okay.
nope, because there's different ways that you can solve that.
Okay.
On your test or your quiz, I would write out what you did. Like you said, you multiplied.
Yeah.
I would do that just so if you did make a misstep somewhere when I'm grading, if I don't see any work, I take off all the points. But if I can see like some correct steps, I'll give you partial credit.
Okay.
Okay, but no, like if you're doing your homework and stuff, you don't have to write that out. Okay, now we found the coordinates of M. Now we have to find the scale factor, which remember the scale factor is the similarity ratio. Now there are two correct answers here. So it doesn't say what to compare first. So if you compared 10 over 4 and you reduce that, you would get 5 over 2. Or what if you did 4 over 10? Then you would get 2 over 5. So either of those are correct. Okay, so 5 over 2 or 2/5. Okay, so on your test or quiz, you could put either one of those and it would be correct. Alright, now this is where the real fun begins. Okay, so you are given a series of points, and then what you're going to do is prove that the triangles are similar. So first, let's just review the ways that we can prove triangles are similar. Okay, you can use angle-angle similarity. Do you guys remember the other ones? Yep, side, 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 and side, angle, side. Okay, so those are the three ways to prove it similar. Okay, so let's plot these, and then you are going to get a better picture of what we want to do. So I'm just going to use some markers just because it'll show up a little better. Okay, so for A, I have -1, 0. And then B is -4, 5. Bless you. And then C is 2, 2. Bless you. All right, and D is 2, -1. Oh, and I do like to label those. So this is A, B, C. E is -4, and then 9, which is 7, 8, 9. So we're going to have to estimate that a little bit. It is off the charts. And then F is 8, 1, 2, 3. Alright, and then I just graph D, E, F. Okay, so what we're going to do is just analyze what we have. If we could use angle, we want to look for any angles that are the same. Are there any angles that are shared here that are the exact same? No. Okay, so there's no shared angles. Okay, are there any 90-degree angles? Okay, so nothing that was given. You could find your slopes and verify that as well. Okay, so that means we must use what? The side, side, side. Okay, so if we're going to do that, if we're using side, 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 what do we know about all the sides? Yeah, they're all proportional. So we have to find that they're proportional, which means AB would be over DE. That ratio would have to be equal to the ratio of BC over EF. And that would have to be equal to AC over DF. Right, so if I'm going to do that, I'm going to use what to find the length of these guys? It's a good old buddy of yours. That too, but what else? The distance formula. Yay! Okay, so the distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, so the first thing we're going to find is AB. So what I like to do for this is I'll write out my A and my B. So -1, 0, and then -4, 5. And I think of it as x1, y1, x2, y2. And then I can see it when I'm plugging in. Now, because we're going to be doing the distance formula many times, you might just want to try to do some of this in your head. Like this is -4 minus -1, which is really going to be what? What's +1, right? So -4 plus 1 is what? -3, so it's -3 squared. So that's what I mean by doing some of it in your head. And then 5 minus 0 is 5. Okay, so then this would be 9 plus 25, which is, what's 9 plus 25? 34. So then that's the square root of 34. Okay, so now I'm going to find DE. Okay, and then if you want, you can also just use the points from up here. So if this is DE, -4 minus 2 is, -4 minus 2 is -6. -6 squared is 36. Okay, and then 9 minus -1 is what? 10, right? So 9 minus a negative is really plus. Okay, so it'll be 9 plus 1, which is 10. 10 squared is 100. Okay, so what we're going to do is we're going to set up our ratio to see what it is. So AB over DE is root 34 divided by root 136. So let's go ahead and do that in our calculator. Let's see what we get. For because some of the other ones might not be the same number, but they could have the same ratio. So that's why we want to check it. So root 34 over the square root of 136. Oh, look at that. It turns out pretty nice, doesn't it? Right? If you want to do it by hand, it's a fraction that you can reduce. Does 34 go into 136? Yes, it does. How many times? So this is like the square root of 1/4, and the square root of 1/4 is 1/2. You'll definitely be doing that if you're going into Algebra 2 honors. All right, and then the next one we have to show is BC and EF. Okay, so I'm going to do BC first. Okay, and instead of just watching me do this, you really should be doing it yourself instead of just copying down what I'm doing. Okay, because then I'm the only one thinking and you're not. Okay, so if you want to try that and then just check yourself with my work, that's an excellent thing.
Is it possible to just do rise over run and find the slope for each line?
But that would only tell you if they're perpendicular. It wouldn't tell you the distance.
But if they're similar, it's like the ratio, isn't it? To find the slope.
You mean like for the side length?
Yeah.
But your side length you aren't going to know. I'll come back and I'll see. And I'll give you guys time to do that. Okay, and then we'll check it. Okay, so I want you to do the distance and look at the rest of them.
That's for the slope for each side. And we already got the like these early. For similar triangles, they are
If you, okay, but they're going to be similar even if there's a rotation. So if this triangle was rotated this way, then you wouldn't have the same slope, but they would still be the same. You know what I mean? Like you'd have like the negative ones there. So I want to tell you that that's more negative. I want to see if it would work with other equations. Okay, so what did you guys get for the length of BC? What did you guys get? Yeah, the square root of 45. Okay, so let me just double check that you're doing this right. So for B and C, if you do 2 minus negative 4, it's plus 4, which is 6. And then 6 squared would be 36. And then for Y, for B and C, 2 minus 5 is negative 3. Negative 3 squared would be 9. So you'd get the square root of 45. Okay, and then so it's BC, it's going to be over EF. So I would just do the distance of it underneath. Okay, so you're going to get 12 squared when you subtract. So you have EF. 8 minus negative 4 is really plus 4. 3 minus 9 is negative 6. So you have 144 plus 36, which is 180. Does 45 go into 180? 4 times. Think of like a circle, right? There'd be 4 45-degree angles, and the square root of 1/4 is 1/2. Just like this one. And then we have one more to prove. Okay, so for AC, 2 minus negative 1 is going to be 3. 3 squared is 9. If I do 2 minus 0, I get 2, which is 4. So that's the square root of 13 on top. On the bottom, I have D to F. So 8 minus 2 is 6. 6 squared is 36. And then 3 minus -4 is going to be, sorry, D to F, you did 3 minus, sorry, I was looking at E. 3 minus -1, which is 4, and then 4 squared would be 16, so you would get 52. Does 13 go into 52? How many times do we think? 4, just like the other one. So and then when you take the square root, you get 1/2. Okay, so see how you could simplify that without your calculator? Alright, so then we say yes, the triangles are similar by SSS similarity. Right? Now, again, when you're doing this on your test or quiz, you're not just going to write that. Like, I'm going to be checking that you have some kind of proof that goes with it. Obviously, for that one, it said to prove it. Okay, so you have to have those steps. Your homework from 7-6 is page 498. Okay, so this one is short, and then you're also going to have a review worksheet that we're going to look at tomorrow before your quiz. So I will hand that